Good morning, this is your stats sensei, Mr. Spensei, and this is a warm-up on the T distribution, specifically a hypothesis test. So, a medical researcher is testing a new drug to determine whether or not it slows the growth. That's an interesting word. That's probably going to help us with our alternative hypothesis. The average growth rate for this type of tumor in rats is 6.2 grams per week. Without going much farther, I'm a betting that that's our mu. That's what it's been, 6.2 grams. The new drug is tested on 30 randomly selected rats. Nice to know it's randomly selected, but we also have our sample size right there of 30 out of a study of 500 rats. So we have a population here of 500 rats that have the tumor. For the rats treated with the new drug, it was found that the average rate of growth for the tumor for the sample was 4.1 grams. All right. So there are X bar, the sample mean is 4.1 grams, with the standard deviation from the sample of 2.8. And being the standard deviation from the sample is what makes this a T distribution. If it was the standard deviation of the population, if we'd had this, it would have been a Z. Run a test of at the 2% level of significance. So they're telling us they want alpha equal to 0.02. Please remember, always divide percents by 100. So if we're running our T distribution, our formula is going to be simply T equals X bar minus mu S divided by the square root of N. Well, then we need to identify our information. Well, we already said the population mean is 6.2. We noted that the sample mean was 4.1. We also noticed that the sample standard deviation was 2.8 and that we had a sample size of 30. All right, so they randomly selected 30, and I'm going to go ahead and put grams here. Not so much that it's important here, but I think it's useful elsewhere. All right, so for a procedure, we only took one sample. Yes, our sample size was 30, but we only took one sample. And so this is a one sample t-test for means. And if all you have is one sample t-test, that will be great. All right, one sample t-test, but it's specifically for means. All right, we can go ahead and now that we have all of our labels, we can go ahead and draw our picture. Please remember the hypothesis tests are always centered on the population mean. So in this case, we're going to be centered on our mean, and our mean here is 6.2. And we have an X bar right here of 4.8. Okay, so the 4.8 is definitely be lower. And the reason we know we're circling down here is because it says it slows, it reduces, it's making it smaller. Well, we can go ahead and plug in. And for X bar, we're going to plug in 4.1. For the mean, we're going to plug in 6.2, standard deviation 2.8, and our sample size of 30. All right, let's go ahead and run this test real quickly. So, stat, test, t-test, which happens to be number 2 on the TI 84. Press enter. Make sure we highlight stats this time because we did not put data into L1. Well, our mean was 6.2. That's the population mean or claimed mean. The sample mean from the lab rats was 4.1 with a sample standard deviation of 2.8 and a sample size of 30. And we said that we were going to slow or reduce the rate of growth. When we push it, we end up getting T equals negative 4.107, and that equals the p-value. Now be careful with that. It's written as 1 point, well, first off, probability T less than negative 4.01079. That came straight off the calculator. But we also have 1.49 e to the negative fourth. That means I need to move this decimal place 1, 2, 3, 4 spaces and put in 1, 2, 3 into the empty cheeks. Another way to look at it is if that's a 4, I'll need 3. If it's been a 5, I would need 4 zeros. So in this case, my probability is 0.001. All right. We still haven't written what our hypothesis is. Well, our hypothesis is that it hasn't changed, that it's still 6.2. So our hypothesis is the mu is 6.2 grams. The alternative is the mu is less than 6.2 grams because we said it was slower. All right. They said they want to see if it slows, and that gives me that key phrase there. So if our p-value is 0.001, that's definitely less than the alpha that they gave us at 0.02. So our decision is to reject the null. All right. Continuing on, bolts. A hardware manufacturer produces a batch of 4,500 bolts. So this sounds like my population size, which is important for conditions, to assemble various machines. Suppose that the average diameter of a simple random sample of 50. So in this case, we know we have a sample size of 50 bolts, has a sample mean, an X bar, equal to 5.11 with a sample standard deviation, so an S equal to 0.1. All right, sample mean of 5.1 and a sample standard deviation of 0.1. Because we're working with the sample standard deviation, this tells me that we're working with the T. Now it says construct a 99% confidence interval for the bolt diameter. Okay, so in this case, my formula is going to be T equals X bar, or not T equals X bar plus or minus T star S to the square root of N. Well, first off, let's deal with that T star. To do T star, we're going to have to go second vars, inverse T, parenthesis 1 minus 0.99, close the parenthesis, and divide by 2. Degrees of freedom has the formula n minus 1. So in this case, it's going to be just 50 minus 1. Press enter a couple times, and we end up getting 2.6799. Please choose to use the positive. So this is what that looks like right there. All right, so now we have our T star. Well, we identified our information already. We already said this that the sample mean was 5.11. We knew that our sample size is 50. We also know the sample standard deviation is 0.1. Now I'm going to put an mm just to remind us that these are millimeters. And the degrees of freedom, don't forget how it follows the formula, n minus 1. So degrees of freedom is 50 minus 1. Or if you prefer, you could have just written 49, but we like to know where you got that from. All right, when we draw our picture, confidence intervals, unlike hypothesis tests are centered on the mean, population mean, whereas confidence intervals are centered on the sample mean. So our sample mean is X bar, so we're centered on 5.11, and we're going to have a 99% here, and we're going to calculate a lower and upper bound. Well, if I plug into my formula, we're just plugging 5.11 in for X bar. We're plugging in the T star, which we calculated right here, so that came from here. 0.1 was our standard deviation, and the square root of our sample size of 50. Well, even though we have a sample size of 50, we only took one sample. So this is a one sample T interval. All right. And if all you have is this is pretty good. One sample T interval. Now, specifically, it's for means, but one sample T interval. All right. Let's go ahead and calculate this confidence interval. So to do that, we're going to go to stat test, and we're going to drop down to number 8, which is T interval. Stat should be highlighted. And our X bar in this case was 5.11. Our sample standard deviation is 0.1. Our sample size is 50, and we want a 90% confidence level. So we find that our bolt diameter is somewhere between 5.07 and 5.1479. All right. So 5.0721 to 5.1479. With this being the lower bound, we're not expecting it to be smaller than this, nor are we expecting it to be larger than this. All right. I appreciate you watching and hope to see you on the next one. Thank you.